Fantastic. So just quickly, my name's Landon. I'm the chair of the technical committee at the Australasian Dark Sky Alliance. Today, we don't have, do we call you a special guest appearance like Graham, come from the clouds? But Graham was originally going to give this presentation, then wasn't, but now thankfully is back in Australia and is more than happy to be with us today to present smart lighting controls. So Graham's worked in a wide variety of public and private sector, public lighting, smart lighting, and energy projects over more than 2 decades in Australia. So, Director of Next Energy Lighting, Emerging Technology Advisor to IPWEA, Program Manager of the SSROC Street Lighting Improvements Program, and sits on the Standards Australia Committee for IT 269 Smart City Systems. So, right in the thick of all of this is Graham. Graham has a Bachelor in Mechanical Engineering from the University of Toronto, Masters in Business Admin, and a Masters of Global Smart City Management. So that is pretty impressive, Graham. So I'm going to mute myself. Thank you very much for your time today, and I'm going to hand this over to you. Thank you.
Thank you very much, Landon, and thank you to Marnie for the invitation to speak today. Um, my goal today is to give you a basic primer on smart controls and convince you that even though it sounds like an obscure piece of technology, that you should be actually quite interested in it and considering some advocacy related to smart controls in the work that ADS is doing. So I thought I'd begin, and I don't have many slides here, and it's a relatively small group today, so please feel free to put anything you have as questions in the chat. I think Landon's going to try and manage that. I thought I'd begin today by showing you this image from France, and I think Marnie did put out a post about this a couple months ago, but this is really reflective of the fact that 62% of the 19,000 plus French municipalities have adopted smart controls and are doing pretty aggressive dimming and off-peak shutoff. There's a lot less light in France at night than there was 10 years ago, which is the opposite of the direction of most countries. Now, there's no question that a lot of this is related to the war in Russia, and the quadrupling of power prices sent many municipalities into a complete panic because they couldn't pay their bills. But what's interesting in this context is the tool that they use to do that, which is smart street lighting controls. And we're going to talk a little bit about that and what the opportunity might be here in Australia. So just a few basics. First of all, we have about 2.5 million streetlights in Australia. We are an incredibly utility-dominated market. So the electricity distributors that serve you in most parts of the country own the street lighting that's sitting on the wooden poles and sometimes underground supplied steel poles in front of your houses and apartments. The councils and road authorities own the rest of the street lighting. Um, and in this context, worth keeping in mind that 70% of the lighting is on residential roads. We have some of the lowest levels in the developed world on those residential roads. The reason why that's significant is that there's very little potential for dimming and trimming, which is something we're going to talk a bit in a bit of detail about. The really interesting part is that 30% that's on main roads. It's more than 50% of the energy, and therefore more than 50% of the light that's produced. We're going to talk a fair bit about that. We're at about 75% LED adoption so far across the national street lighting portfolio. That's going to hit 90% plus within 3 years, I would think. And the reason LEDs are key is because they're infinitely controllable. And so smart controls really go together with LEDs. Now, the other pot of lighting that we have in the public domain is somewhere between 1 million and 1.5 million other public lights. They're very fragmented. They're owned by universities and mine sites and military bases and private developments and retirement homes, big hospitals, large university campuses. There's a huge array. They tend to come in much smaller groups of lighting, tend to not necessarily be managed by folks who know a great deal about lighting. And I would suggest that probably only 30% of those have been converted to LEDs so far, and there's very low adoption of smart controls amongst those groups. So smart controls. I've got a couple of samples here. They're about the size of a coffee cup. They sit on the top of the lights generally. They replace something that was about this size, a photocell that we've used for decades. And they are effectively a mini computer and have communications inside them, as well as generally a utility grade metering chip and a GPS chip. And they go into a standard interface on the street light, and they're relatively interoperable. So you can use brand A's smart control on brand B's light or vice versa. Um, they are proven in terms of energy savings. They deliver a lot of important information for maintenance and the administration of public lighting. They will tell you when they're not working. Some of them even have a last gasp feature when the power goes out. They tell you all sorts of information about the light, how much energy it's using, exactly where it is with the GPS chip. Um, Lots and lots of other benefits. We're not going to talk about those other benefits. We're mostly going to talk about the energy savings benefits because that directly impacts the lighting load. But just important to know that these are really interesting devices that have come a long way over the last decade and are really well proven now. And I'll show you an example of what a utility or a council would see in their central management system. They're almost all very similar, these interfaces for these control systems. You get a map and you can see, 40 or 50 lights here. And one of them has a different color. And that's because it's not working or there's some kind of fault. And you can then go in and investigate that. And you can use them for reporting more widely. You can use them to set trimming and dimming, which we're going to talk about, as well as all these asset management benefits I mentioned. Now, even though you might not have heard of smart controls for lighting, they are a proven technology backed by large, credible vendors. The four biggest in this country have each sold more than 1 million devices worldwide. And in fact, there's more than 30 million smart controls deployed globally. It is, in my view, easily the most successful smart city technology. It's being used across the developed and the developed world. In Australia, we have relatively low adoption to date, and most of it is on networks other than the utilities. Maybe about 200,000 adopted to date. There's about 4 big deployments, and we can talk about that if anybody's interested. So I mentioned that there's a lot of benefits. The ones we're really interested in are the ones on the far left. We're going to talk about trimming and scheduled dimming and something called constant light output and adaptive dimming. These are the ones that really have a material effect on dark skies issues. So trimming, interestingly enough, in many early analyses is actually the biggest single opportunity, and that is really just waste. It is lighting above that required for compliance with the standards. And we'll talk a little bit about why that's there and how we haven't really been able to do anything about it historically, but we now can. Dimming is about reducing lighting levels when they're not needed. And a very typical profile might be, dim to the next lighting category down at 11 p.m. and then raise it back up again at 4 or 5 in the morning. This is happening widely around the world, not just in big cities, but in many smaller cities. For example, in the UK, there's about 70 councils doing off-peak dimming, or in fact, off-peak shut-off in rural areas is really quite common. A constant light output refers to holding the lighting level over the years. We used to overlight because we knew the lights decayed as they aged, and we wanted to still be compliant on the last day of their life. We don't have to do that anymore. We can actually light exactly to the compliance level and gradually ramp up the power over the life of the luminaire so that we keep the light output constant, and that saves another 4% over time. So it's small contribution, but everything helps. In the bottom right-hand corner is an illustration of what we mean by adaptive dimming. So once you have systems like this in, you can use Google data or sensors or a number of other inputs to move the lighting level up and down in response to changes in conditions. If there's a big storm, you can ramp it up. If you sense there's very, very little traffic, you can take it down a lighting category or even two. The hope with these adaptive dimming projects is that you can actually save even more than scheduled dimming, but they do come with a bit of technical and IT complexity and haven't been as widely adopted as scheduled dimming, at least to date. Now, I thought to illustrate what I'm talking about, I'd show you a real world example. This is a main road in Randwick, and the real world's incredibly messy, and lighting is not as per the lighting courses that people like Landon or I might have done. It's all over the place, especially when you're on utility poles. You can't move them, and they're just where they are because of intersections and driveways. And so you get sections that are wildly overlit, and then the next section might be wholly non-compliant because the gap is too long. And you can see that there's a red bit in the middle. Well, we've got a big section of non-compliance there, so we're not going to touch trimming in that area, but you can see the lights either side of that have different potentials for trimming. And then we can dim in the middle of the night to the next category down. You can see that, some of those can dim very markedly. So if we look at the one on the bottom right, you can see that we can trim it by about 20% and still be fully compliant with the lighting category for that road. And in the middle of the night, we could dim it by 60% and be compliant with the category that would assign in the middle of the night. Now, what matters is not the messiness, but what the averages are. And trimming actually turns out in our analyses to be a bigger opportunity than dimming. And that's really important because trimming is almost entirely non-controversial. Nobody wants to be wasting lighting, wasting energy, and paying higher bills. Even the main road authorities are likely to be happy with trimming because it'll actually improve uniformity on the roads. And so we think the trimming potential from the analysis we've done around Osgrid here in Sydney is about 20% on average over the main road network, that we could probably save another 15% in the off-peak by dimming, and that constant light output might add another 4%. So that would take us to about a 39% average reduction in energy, but also in terms of light load. And that's very, very significant. So we're knocking something like, getting close to 40% of the total load off through the night on average. Interestingly, this is really similar to figures produced by others in different jurisdictions. I think it's a function really of the behavior of the old utilities, where they put the poles, what the average spacings were, what the heights were of lights. It's all follows a pretty similar pattern. And it's not because this messiness is not because of anything to do with lighting. It's more just a function of the locations and standard practices of the utilities with their old poles. And we really haven't been able to do anything about it in the past because we didn't have access to tools like smart controls. The lights were pretty lumpy. You had to buy a 150, a 250, or a 400 watt HPS, a high pressure sodium. And if you needed a little bit more, kind of too bad, you had to jump up to the next category. So there's a lot of inefficiencies in what was done historically, but it's just a function of the technology that existed at the time. We've also this year done about 400 analyses of pedestrian crossings. We have a new pedestrian crossing lighting standard in this country. It's a fairly significant change. Again, we're finding that the trimming opportunity alone is getting close to 30%, simply because the new standard has come down a little bit and of that lumpiness I mentioned before. So that's just completely wasted light, leads to a lot of resident complaints for the poor people living near these pedestrian crossings. Doesn't add to compliance in any way, and we can just get rid of that if we put smart controls on pedestrian crossings. So the final thing I'll mention technically is the importance of sensors. So we talked about smart controls that sit on the top of the light. For those of you that live in Sydney, you might have seen lights that look like the one on the right. They have this funny little thing sticking out the front, which is actually an additional sensor port. And what we're seeing internationally now is the emergence of sensors to help with trimming and dimming in the off-peak especially. That they can be motion sensors. Those are more appropriate for things like bike paths and park pathways, or they can be devices that are measuring traffic volumes and then gradually changing the light every 15 to 30 minutes. That would be more typical of how you do it on a main road. And the reason I mention this is they kind of go together with smart controls. These two technologies are sort of moving in parallel. Sensors probably emerging a little bit later than the smart controls, but increasingly are going to be important because they'll be useful inputs to the smart controls and how they operate. So without making this too obscure, I thought it was worth talking about what's going on with the national electricity market, because this is a really important rule change. It determines whether councils and road authorities are actually going to get a financial benefit from dimming and trimming. As of today, you can dim and trim all you like. You can even turn the lights off in the middle of the night, and you'll get absolutely no financial benefit from that because the lights are not metered individually. It's just done by a load table, and it assumes what the consumption of the light is, and it assumes that it turned on at sunset and turned off at sunrise. What's happening in the national electricity market is they're introducing something called Type 9 metering, which takes effect next May and will recognize the dimming and trimming that councils and road authorities do and then give them financial benefit for that. Um, Similar reforms in places like the UK and New Zealand and parts of the United States have led to really widespread uptake of smart controls. And so I think it's important to realize that even though this is an obscure aspect of the national electricity market, this kind of reform has a profound impact over the medium term in terms of how many of these devices are ultimately going to be adopted. So just a couple things to finish off in terms of advocacy. What might add to think about going forward? Well, I would certainly, if I was in your position, think about advocating for smart controls being deployed everywhere. It's not only leading to better asset management and safer roads, but also to all of these benefits in terms of reducing the load that lighting has on the night sky and the environment. I would advocate for the utilities councils and the road authorities and all of these other parties that own public lighting to trim the excess, to adopt constant light output, and to dim or shut off in the off-peak. Uh, there's, as I said earlier, very, very strong national precedent for that. I would think about advocating for improved rules in the national electricity market to provide incentives for everybody to adopt these systems. The rules that have been proposed by the regulator look pretty complex and potentially expensive to implement, and that might reduce the incentives for everybody to pick them up. And I would think about advocating for sensor-based lighting. There's no need on a Tuesday at 2 a.m. to be going full bore in the same way that we are during rush hour when roads and pathways are little used, if at all. And sensors allow us to be really dynamically responsive to the presence of vehicles and people. Just in terms of making you aware of what's out there to help some of the people you might be advocating, there is now a widely adopted model public lighting control specification. The Institute of Public Works Engineering developed a few years ago in conjunction with about 20 different stakeholders in this area. It's been used in many of the early smart controls tenders, and it just takes a kind of technical risk out of it for people who are unsure about these new technologies. And there's actually a training course that people can do that goes along with that. So I will stop there. I'm very happy to take any questions people have. I think that just to put this in context, cutting and wasted energy consumption by 20% and potentially going another 20% with dimming and constant light output controls is as significant as any other measures that could be taken, including the color temperature of LEDs that many people have focused on. I think this is a very important technology to actually reducing the dark sky load and the environmental load of public lighting.
That's beautiful, Graham. Thank you very much for that. That's fantastic. And from ATS's point of view, we 100% agree. We've long believed that controls are probably the most important of any of the measures that someone can take in the public space. So appreciate you shedding some light on some of the technologies. If anyone does have any questions, please pop them into the chat area. I just have one that might be a little bit obscure just to kick things off, Graham, but you mentioned the trimming of lights. I'm assuming currently that's done in software systems where we look at what's actually happening in a computer world. With the amount of ambient light that we have in our cities and towns, has anyone ever actually done any real life measurements and then looked at the trimming potential with the contribution of ambient light in the city, or is that not recommended because ambient light in the city isn't constant, or?
Um, as I read the standard, the 1158, the road lighting standard, you're not really allowed to consider the ambient in your calculations. And so I think the answer is nobody's really looked at that. And the challenge with that ambient light is it's highly unpredictable. It might be, ludicrously high at 9 o'clock at night from a car yard, but then they turn it all off at 11 o'clock. So you can't really count on it being there from a road safety perspective. So I'm not aware of anybody having looked at that.
Very good. I know in interior lighting in offices, we use a lot of light sensors that actually measure the real-time contribution, and maybe there's a future where street lighting can do the same.
Possibly. And I think that's one of the reasons I raised sensors. It's an emerging area. It's a little bit unclear what benefits it's going to drive, but I think it's going to change enormously over the next few years. And sensing the ambient light levels is definitely one of the options.
question from Brian, which is a little off topic, but it might be something you can shed some light on, Graham, with
Hmm.
your past experience. Brian's asked that he noticed that these smart lights don't have shielding, one of the requirements for so recommends, which is true. Do you have any comment on that in regards of our street lighting market and the lack of shielding?
So I think to me, and I'll just be perfectly blunt, shielding is a little bit of a furphy with LEDs. Uh, LEDs uh, are almost point sources, and you can have optics sending them wherever you want and don't want uh, almost perfectly because of their tiny size. The old lights were big envelopes with arc tubes inside and basically just splashed light everywhere. But with the LEDs, you can have the light up to the edge of the property boundary and have very, very little light beyond that. And that has nothing to do with adding extra shields. Extra shields make people feel like there's more control. But I think what really matters more than the shielding is the actual optics of the lights. And the utilities generally now not only are making sure that the new lighting is compliant with the standards, but in many cases are being asked to ensure that it's compliant with another standard called 4282, which is about the control of obtrusive light. I think that's much, much more important than individually shielding one or two lights. I think that would be what I would focus on is getting widespread adoption of 4282 by the utilities, road authorities, and the councils. I think that'll have dramatically more impact than decisions about shielding.
Yep, and that's a very valid point. And 4282 is, of course, not required by the street authorities unless the council actually requests it. So it's
That's right. So that's why I would be advocating for it because I think it's something that is within your purview to advocate for, and it'll make a difference.
very good. James is probably a little bit more of a statement, but cost of smart sensors are about three times the price and more expensive of retrofitting existing LEDs. So best to have luminaires pre-fitted with smart sensors at the time of installation. Is that cost about three times as what you guys are seeing in the market, Graham?
The cost of the sensors, for example, a motion sensor on a bike path can be very low now. They can be as low as $100 or less. What's really expensive is sending two people in a bucket truck to the site. That can be $1,000. So it can be 10 times the cost of the sensor. So I think the point is a good one. If you're going to install any of these technologies, do it when you're there to install the new light. Retrofitting is really expensive. And as you get to main roads, the tr cost of traffic control is absolutely horrendous and can sink the business case for lots of these technologies, particularly if you just want to do that light or that intersection. So when you're doing a whole roadway, that's the time to think about these technologies. You don't want the second truck visit if you can possibly avoid it.
And these lights these days, they can be sort of, if you want, made future-proofed with this technology. If, say, if a council wasn't ready necessarily to fit the sensors and the smart control at the time, can you have it sitting there idle, or is it something that has to be
Yep.
done when the lights installed?
Most of the lights um, are by default now ready for this. You would need to ask the suppliers for that extra sensor port. That doesn't come as a default, but it adds about $20 to the cost of the light. The smart controls can be added to almost any LED that's been installed in the last 5, 6, or 7 years. So that, yeah, they're all basically future ready.
Excellent. Just one other question that I have on this. And, we're very excited by the top nine metering. We think it will have a profound effect in this country. But you mentioned there's already been four big deployments. So, out of our interest, being that there wasn't obviously a financial payback in terms of the energy saving, what was the motivating factor for those four big deployments to be able to get smart lighting?
So they're all a bit different. Transport and main roads in Queensland has a big deployment of 30, 40,000 that is sitting behind the meter. So for them, if they do any trimming and dimming, they'll save money today. Excuse me. Um, I think though that their motivation was mostly about road safety and managing maintenance. Um, the councils up in the Northern Territory, again, they own their own lights now, and they instituted smart controls from about 2019 onwards, and can use those to dim and trim as they see fit, and have a different regulatory system up there. Uh, Osgrid, the big deployment here in Sydney, well, and I work for the councils in this region. That was really just to get ready for Type 9 metering. It's quite recent. Certainly, there's all these other benefits like getting rid of night patrols and better asset management that are important. Improved road safety, but clearly trimming and dimming are big motivators going forward. We're about to start seeing many councils in this country face 60, 70, 80% power price increases as their big long-term power price rolls off. It is very attractive for many of the councils. And so our expectation is that many councils, particularly after this rule formally kicks in, the metering rule next May, will be very keen to pursue trimming, dimming, and anything else that will save energy because they're going to be facing quite a cliff in terms of their power bills. Power Core deployed with Melbourne and Geelong, down in Victoria. The motivations for Melbourne are a little bit unclear. It's not being used to do trimming and dimming, and they don't even have a central management system to this point. So a little bit unclear what the motivation for that is. Geelong is a little bit more like the councils in Sydney. The other big deployment is in the ACT. And again, it's a bit of an exception because they uh, control their lighting. It's not managed by a utility, and so they directly benefit from the trimming and dimming if when they implement that. So yeah, it's a bit mixed,
Bit of mix.
bit of mix, and a
As you
lot.
say, hopefully come May we see a big uptake with the.
Yeah, and we're at about 6 to 10% in Australia adoption. In New Zealand, they're heading towards 75%. The UK, where they have reasonable rules, is above 40%, and some of the big states in the US, like Georgia and stuff, have widespread adoption. Hundreds and hundreds of thousands of these devices deployed.
Actually, probably a timely question from Alex then, which feeds into this. Just says I'm confused by the trimming. If we're trimming, does that mean the lighting design hasn't been done correctly? Which is I
No,
guess, a legitimate question.
yeah, it's a really good question, and apologies if I didn't make the point clearly, but it's really a function of just the messiness of the real world in the past. Pole spacings are all over the place. And if you needed, 175 watts of lighting to comply under the old technology, it was kind of too bad. You had to move up to 250 watts because there were only three different common wattages available to the utilities. And, it's like the old 60, 75, and 100-watt lamps in your house. There weren't 82 watts versions, 82-watt versions available of those lamps if that's what was needed. And so it is really just a function of the limited nature of the old technology and the lumpy nature of it. It came in fixed wattages, and that's the only choices people had. Now, what suddenly changed over the last 10 years is LEDs are incredibly controllable, and smart controls allow us to control them infinitely. And if you don't like it, you can unwind it from your laptop tomorrow and do something different. Um, and none of that was possible 10 years ago. So hopefully I've explained it. Happy to take more questions on that if I haven't done a good job.
Well, Alex has also come back, so it only applies for retrofits, but I think that's not necessarily the case either, is it, with pole infrastructure?
Yeah, it really only applies to LEDs in that are being retrofit onto existing utility lighting. And keep in mind, in many of our cities, 75% of the lighting is on wooden poles, where the lighting design was absolutely not part of the consideration. You just have to work with the pole you're given. And sometimes the poles are too close, sometimes they're too far apart. It's really messy. In a new subdivision, I would agree. It's a perfectly valid point he's making. That would be designed in a more optimized way in lighting design software to match the lighting exactly to the compliance requirements. So we're mostly talking about here the very, very large legacy of existing lighting. And keep in mind, the lighting only expands, the number of lights in this country only expands on streets by 1% a year in line with population. So the vast majority of this story is about retrofit.
Very good. Just another one here from Brian. I've been told that these lighting controls can detect the vehicle approaching and automatically control lighting.
So that's not entirely right. It's not about the controls. It's about those sensors I mentioned at the end of the presentation that you can add to the bottom of the lights. Um, they can do that detection and they send a signal to the smart control saying, oh, I've detected a car or I've detected 100 cars over the last 15 minutes. We probably need to raise the lighting level. In general, motion sensors are used on locations like park pathways and bike paths, and they dynamically respond to you as, a cyclist, and they might have the next few lights in front of you and a few lights behind you go up and then gradually bring those down again once you've passed. On main roads, it tends to be more of a counting approach. I've counted 100 cars in the last 15 minutes, and that puts me over some threshold. And so we're going to bump it up to the next category. And in general, traffic volumes are down by about 90% on almost every main road you've ever looked at by 11 p.m. Um, but I think that the point that some of the adaptive lighting folks would make is sometimes there's a late event at the stadium and suddenly that road has tens of thousands of people on it and it looks like it's rush hour. Or there's shift changes at major factories or hospitals and you suddenly get these huge spikes in certain areas. So some adaptive lighting systems are attempting to respond to that by counting the traffic, but they don't tend to generally raise the lighting because they see you coming. It's more about the average counts over a period.
You're right. Thank you. Well, we've had no more questions in the chat, so it does seem like a very good time to wrap things up and to say thank you very much. Your expertise has been brilliant. It's been wonderful to have you share it with us today. So really do appreciate it, Graham. Thank you. Thank you to everyone who has attended. A quick reminder, obviously the Australasian Dark Sky Alliance is a not-for-profit organisation. We do rely on membership. So if you have participated in the webinar and you're not a member, please do sign up, or a past member, please renew. And a final point, while you're on our website, just remember that on the 24th of November, Federal MP Tony Zappia will be putting a motion forward to Parliament for the investigation into legislation to reduce light pollutions. We have a letter you can download on our website that you can actually send to your local MP to get their support for that motion, which would be very much appreciated as well. So, Graham, thank you again. Really do appreciate it. And thank you everyone for joining us.
Thank you, everybody.
Enjoy the rest of your day. Take care.
So, as long as people can borrow against them.